Okay, now I'm going to show you an example of using the equilibrium equation to solve a problem. Okay, so in this problem, determine the tension in the cable. Okay, here is cable from point B, D, and let's say this point E. Okay, and the horizontal and vertical component of reaction at pin pin A. So here is A, pin connection, and here is C. Okay, the pulley at D is frictionless. So this pulley is frictionless. So, and the cylinder weight of 80 Newton. So here is 80 Newton. Okay. So what I'm going to do first thing is we need to draw the free body diagram FBD. Okay, to solve any problem we always start with the free body diagram. So first we sketch, okay, the body, the frame here, okay, and then we put the Asian loading. Okay, we have only a single force of 80 Newton at the end of the frame, and then we have reaction force of your reaction force at joint A. Since joint A is a pin joint here, so does the frame can move left and right? Okay, no, because this support prevent the frame from moving to left and right. So we have the reaction of AX. Does the frame can move up and down? No, because the support prevent the frame from moving up and down. So we have a Y. Can the frame rotate? Yes, of course it can. Okay, because it's pin joint, so there is no reaction moment here. And next, the cable. Okay, you need to understand the principle of cable. Okay, at all time the cable, okay, give a reaction this along with the cable. Okay, the direction of the cable. So it's going straight upward. So we pull, okay, the reaction upward, and at joint E, it at the angle of 1 to here is 1 to square root 5. Okay, so similar to this is with the angle of 1, 2, and square root 5. Okay, since this is the same cable, so the force at here also similar. Okay, T, and then we label the dimension. Okay, this 5 meter, here is 5 meter, and here is 3 meter. Okay, this point A, point B, point E, point C. Done. This is the free body diagram for this problem. Okay, so from this free body diagram, what is the unknown values? Okay, that we can identify here is AS, we have AS, we have AY, and we have T. So these three unknown values. So actually in 2D problem, we can solve maximum 3 unknown values, because from 2D problem we can generate, okay, only 3 equilibrium equation. Okay, what is the equilibrium equation? First is the total of moment equal to 0. Okay, counterclockwise as positive. So the first question, okay, where is the position of the moment that we can take here? We can take first at joint A. Actually we can pick up, okay, the moment at any point here is at the A, B, E, or C, but the most wise position to take is at joint A, because if we take the moment at joint A, at point A, we going to eliminate the AS and AY here. Okay, and directly we can solve the T the value of T here. Okay, so the moment at joint A is, okay, so we got here is first the force of T, okay, with the perpendicular distance is 5 meter, is counterclockwise, so it's positive. Next is this one. Okay, so we need to resolve to Y component first. Okay, so it's going T times 2 square root of over square root 5, and the perpendicular distance is 10 meter. Okay, and it going to rotate also counterclockwise, so it's positive. And then we have the 80 Newton here. Okay, 80 Newton times width, the perpendicular is 13 meter. Okay, it's clockwise, so it's negative, equal to 0. Okay, so directly from this uh, equation we can determine what is t. So t is equal to 74.6 Newton. Okay, and then next equation is the total of forces in y direction or x direction equal to 0. The total force in y direction is upward as positive. So we have first is ay, positive ay, and plus t, and plus t 2 over square root 5 minus 8t equal to 0. So from here we can get ay, display the t inside this equation, then ay equal to 33.4 Newton. So it's, since it's positive, so it's going to be negative 61.29 Newton. Since it's negative, that means 0.3 Newton is downward. Okay, and then the next one to the right is positive. The total of fx equal to 0. So we have fx as minus t times with the 1 square root over square root 5 equal to 0. So here we can get t, ax equal 33.4 Newton. Since it's positive, so it's going to be to the right. Okay, done, finished. We have got all the answers here. Okay, here is t, here is the ay, as. Okay, these three answers. Okay, next I'm going to show you another example, okay, of this problem. Right, determine the direction on the bend road which support by a smooth surface at B and by a collar at A. Okay, here at A we have collar support plus fixed connection. Fixed, okay, different is fixed connection with the collar. It has smooth road here, and at B here, okay, at joint B here we have rocker on smooth face. Okay, so you need to understand, okay, the kind of the type of the support and how we are going to replace the support with the reaction loading. Okay, so here next we need to draw. First is the free body diagram. Okay, so previously I've shown you how the free body diagram of this structure. Okay, so I write them again. Here we have first the sketch of the frame, and then the action loading. Here we have 100 Newton. Okay, so here we have the couple moment. Okay, 200 Newton meter. Alright, and next, okay, what we have is the reaction force at the collar. Okay, here is, we call it as FA. Alright, with the direction of 3, 4, and 5, and here we have the another direction at the rocker. We name it as FB with the direction of 12, 5, and 13. Okay, and since this is fixed support, so at here the frame cannot rotate because it's fixed support. So we have reaction moment here, we call it as MA. Okay, we don't know, you can put any direction for the unknown forces, okay, or loading. And next we label it as, okay, the dimension here as 3 meter, here as 3 meter, and the height here is 2 meter. Okay, done the free body diagram of this frame. And then from here, how many unknown values that we can identify is, we have one FB, FA, FB, and MA. Okay, we have 3 unknown values, so we need to solve by using 3 equation of equilibrium. So next is equilibrium equation. Okay, equilibrium equation. Okay. So again, the first equation that we can use here is the total of moment equal to 0, counterclockwise positive. So again, which point, sorry, I forgot, this joint point A, here is point B. Okay, so again, it's be wise to take, okay, the moment actually can take is the moment at point A or point B. Okay, so let's say I take the moment at point A. Okay, what is the total moment at point A? Here is we have first the MA. Okay, MA is counterclockwise positive, and then we have the 100 Newton times 3 meter. Okay, it's going to be clockwise, so it's negative, and then we have this couple moment 200 Newton meter. Okay, it counterclockwise also, it's clockwise, so it's negative, and then we have the FB. So we can resolve FB to the component of Fs and Fy here. So what you have going to have is FB 12/13, with the perpendicular distance is 6 meter. Since the vertical is rotated like this, counterclockwise, so it's positive, and we have for the horizontal component FB 5/13 with the perpendicular distance of this 2 meter. Alright, and it going to rotate like this clockwise, so negative equal to 0. So this is the first equation. Okay, the next question is the total of forces, okay, in S direction equal to 0. So what is the force that we have in S direction? First we have the component of FA. Okay, so we got FA with the 4/5 to the right is positive, and then we got this FB. Okay, FB 5/13, the S component, and it to the left, so it's negative equal to 0. This is the second equation. Okay, and then the third equation, the total of forces in Y direction equal to 0. Okay, so first the Y component of A here is FA. We have 3/5. Okay, upward is positive, and then we have this 100 Newton, downward negative, and then the component of FB, okay, is also upward, FB plus FB 12/13 equal to 0, and this is the third equation. Okay, that's all. Then if we solve these three simultaneous equation, then we can get that the FP equal 82.5 Newton, FA equal 39.7 Newton, and MA equal 106.3 Newton meter. And don't forget the direction. Okay, MA since is positive, so is going counterclockwise. FA, FB as shown as the direction in the free body diagram. Okay, so this is another example. Okay, how we are going to use, okay, for this problem. Okay, the most important thing you need to know how to draw the free body diagram, and next how to develop the equilibrium equation. That's all. And then solve the three simultaneous equations since we have three unknown values. Okay, you must remember that in 2D problem we can only find out three unknown values. Okay, because the maximum equation that we can create from this problem is only three equations: the total moment equals to 0, total of force in S direction equal to 0, and the total of force in Y direction equal to 0. So these are only three equations that we can create in 2D problems. Okay, okay, and then I'm going to show you another example. Okay, a bit tricky. Okay, this example. Okay, the 10 km uniform road is pinned at NA. Okay, it is point A, is pin jointed. Okay, if it also subject to a couple. Okay, D road has 10 km weight. Okay, this also have couple moment here. Okay, 50 Newton meter. Alright, and at joint B as spring. Okay, with the spring stiffness 60 Newton per meter. Alright. So when the theta angle here is 0, so the spring is unstressed condition. So what is the minimum theta? Okay, the minimum theta for equilibrium. Okay, actually we need to find what is the smallest theta here. Okay, of course, the first step we need to draw the free body diagram. Okay, this is the free body diagram of the frame here. Okay, if we draw the free body diagram of the frame, okay, so here we have the AS, so the AY, AS since spin jointed, so we have AS and AY here, and then we have the weight of the frame here, so it's going to be 10 kilogram times with 9.8, okay, Newton, and then we have the F, okay, F here, okay, the force of the spring, and is equal to the stiffness of the spring times with the S. S is the extension of the spring, okay, and here the angle is theta. So if you look this free body diagram, how many unknown values that we can identify? All right, here we have first the F, okay, the F in K and S, okay, definition, and then we have theta, we have AX and AY. So actually in this problem we have more than 3 unknown values, so it's going to be difficult to solve it. But the most important thing in this problem is we need to understand the principle of the spring. Okay, what is the principle of the spring? Okay, sorry, we put the dimension there is 1 meter, here to here is another 1 meter. Okay, what is the principle of spring? Okay, we do understand that the spring F is equal to the extension K times with the X, where K here is defined as, if given as 60 kilonewton, 60 Newton per meter. Okay, so we write down is equal to 60, and the X here, what is the X here? So X here is the dimension of the spring, or the extension of the spring, okay, from here to here, okay, is the dimension from here to here. Since the length of the frame is 2 meter, so here is equal to 2 sine theta. Okay, so we have defined the F as equal to 62 sine theta. Okay, so if look at the unknown value here, we have only how many unknown values? Actually we have only 3, AS, AY and theta, because F we have defined as 60 times 2 sine theta. Okay, now because we want to find the value of theta. Okay, next what we're going to do to get the answers, okay, first we take the total of moment equal to 0. Okay, since we are not interested in AS or AY because we are going to find theta, so we take the moment at joint point A here equal to 0. So now what we have now here is, first is the force here at point B here. Okay, what we have is the force of F is 62 sine theta, sorry, 60 times 2 sine theta with the perpendicular distance here. What is the perpendicular distance here? Is 2 cosine theta. Okay, so this force is going to rotate counterclockwise is positive, and then we have this one times tan 9.8 is 98. Okay, with the perpendicular distance here is this. Okay, that means is sine theta. Okay, 1, because this the length here is 1, so 1 sine theta. And then we have the, sorry I forgot, okay, the couple moment 15 Newton meter here, so clockwise, so minus 50 Newton meter equal to 0. So if you look here, okay, in this equation, okay, you only have the term of theta. So we solve the problem, then we can get theta equal to 24.6 degree. Okay, so in this problem, okay, what is the important thing I want to stress here? So you need to understand the principle or the mechanism of the spring. Okay, how the spring working here. Okay, the extension of the spring will produce, okay, the value of the force that we apply to the system. So this very important. And then another thing in this problem is the geometry of the system. Okay, since the extension of spring will create, okay, because the frame, the length of frame is 2 meter, it will not change because this is the rigid body, so the length of the frame is remain 2 meter. Okay, it doesn't change. Okay, so remember it's a rigid body, so it doesn't change. And then we need to know and understand that the extension of the gap of the distance that travel of the point B from here to here is equivalent to the stretch length of the spring. Okay, so this is the trick of this problem. Okay, the solution is very short, but you need to understand the working or the principle of the system. Okay, that's all for the example that I would like to give you for the equivalent question. Thank you.